So as I said, this is a Region 4 meeting. We've got several requests over the last couple of months about blockchain. As you all know, we had a lot of press recently on NFTs, on the wild gyrations of Bitcoin and other things like that. So we wanted to talk a little bit about the practical foundations. We're planning a second meeting where we will try and find somebody who's currently using it as a business model. We've had several outreaches to companies that use it for logistics, purchasing, things like that. So we're going to try and get somebody to do a case study a little bit later. But for today, I'd like to thank our speaker, who's Ramesh Ramadoss, who's if you look on his LinkedIn or this bio in the summary I just sent out, has quite extensive background, but I'll do a quick summary that he's a entrepreneur, author, and researcher, and international speaker. He is co-chair of the IEEE Blockchain Initiative. So again, look in your IEEE webpage and take a look at that. He leads the IEEE Blockchain Standards Committee. He also serves as an expert panel of the European Union Blockchain Observatory and Forum. He received his Doctor of Philosophy in Electrical Engineering from the University of Colorado at Boulder, and has an extensive experience in the industry in multiple positions. So Ramesh, I'll turn over to you. And if you want to add anything else to your extensive biography there, I definitely shortchanged you a bit there. And I really thank you for taking the time to speak to us today.
Thank you, Bob. Okay, here's the outline of my talk. Start with digital cash, and then talk about Bitcoin, and then talk about how this Bitcoin set the stage for a new field called blockchain, and then Ethereum, and then we will look at three different aspects of the blockchain ecosystem: startups, enterprises, and governments. So digital cash, money or currency, refers to any means of payment that is purely in electronic form. In this case, on computer systems, there's no physical paper bill or coin. And since the late 1980s, there have been several attempts to create digital cash. You can see the list here, starting with 1989 DigiCash and eGold and so on, Hash Cash. Finally, in 2008, there was this Bitcoin published as a white paper in a CryptoPunks mailing list back in October 2008. And then the actual code was deployed around January 2009. And it turned out to be the first successful digital cash deployed on a peer-to-peer computer network. This idea did not come out of nowhere. Bitcoin is actually a recipe based on several key ideas. You can see some of them listed there: the public key cryptography, which is widely used, and then 1979 Merkle trees was published by Ralph Merkle, and 1991 timestamping concept was published by Stuart Haber and Scott Stroneda, and 1997 proof of work algorithm was published. In 2001 SHA algorithm was published by NSA. So Bitcoin is basically a recipe, combined all of these ideas and created a new protocol for digital cash. And Bitcoin is a peer-to-peer protocol. It's software. It's just running on this peer-to-peer network. Conceptually, the whole thing is running on a distributed computer network. And then it's basically a ledger. Ledger is like, Excel sheet. You can keep track of, like, I gave $10 to Bob, Bob gave, I don't know, $5 to like Richard. You can, if you were to type those in an Excel sheet, it's a ledger. In this case, it's an electronic ledger, and the copy is stored on each one of those participating nodes. The protocol here is basically the governance rules that determines how the transfer happens from, in this case, Bitcoin, from one account to another account. That's what that protocol layer is. And then on top of it, you have the wallet. Let's say I were to send one Bitcoin to Bob. I have to have an account on the Bitcoin network. Bob has to have an account on the Bitcoin network. The account, it has a private key and a public key. It's similar to, when we have an account on any web application or mobile, there's always a user ID and there's a password, correct? So that's what this is. A private key is like the password. And in this case, it's hexadecimal, like long string of characters, hexadecimal. The private key, just like the password, you wouldn't give it out to anyone. You would keep it yourself. And the public key, you could give it to others. For example, if I want to send a Bitcoin to Bob, Bob needs to tell me his public key. There are different types of wallet. Non-custodial wallet, basically you are responsible for saving those private keys. You could use a custodial wallet, meaning like there are exchanges like Coinbase. You can create an account with them and they would manage all these transactions for you. There are also hardware wallets like USB kind of wallet where you can keep it offline. So ledger is where all the transaction data is stored. So in the case of blockchain, it's a chain of blocks. Like each block consists of batch of transactions. Each block is linked to the previous block through hashing. So this is the protocol. In the case of Bitcoin, it's called proof of work algorithm. A new block is added every 10 minutes. A batch of transactions, right? You group them. That's how a block is created, and then it's added to the Bitcoin network. The folks who do this job of creating a block are referred to as miners. Whoever solves that proof of work algorithm first, they become the winner and they add the next block. So in this case, you can see miner 1 actually added 2 blocks, and then miner 2 basically added the 3rd block and the 4th block. Now, what happens is the longest chain, the one in green color, becomes the valid chain. The miner who proposes the winning block receives rewards in terms of new coins and transaction fees. So if you look at the mining reward as of today, it's about $245,000. Basically it's 6.25 Bitcoin. Mining, the difficulty level used to be low, where do mining with your home computer, or even some students were doing mining using university computers back in the early days. But over the years, there is a difficulty level that's been programmed in Bitcoin where you need more hash rate or computation power to be the winner. So this has created a business model. Big companies started buying like mining warehouses like the one you see here, and they basically create a pool. And so this graph here shows you like the distribution of mining nodes, like 15,200 something. However, these companies here, like Foundry USA, F2 Pool, they own a lot of these nodes. Ideally, each node is run by one person. It's a peer-to-peer, but that's not the case. These are owned by a lot of these companies. So when Bitcoin was launched, it was launched with a predefined 21 million coins. So that's how much you can actually create. The mining reward decreases over time as the supply is increasing. There's a halving process that actually lowers the reward. When the Bitcoin protocol was launched, the mining reward for adding one block was 50 Bitcoins. And then every 4 years, it's been, like you see 50 becomes 25, that's called halving, and then 25 became 12.5, and half of 12.5 is 6.25. Now, this is how it was programmed. Well, that's the hash rate. This shows you all these mining pools are competing to add the next, winning block, and you can see the number of calculations made, like a lot of computation as a result, a lot of energy being wasted. You can see this on the news all the time. Like if you look at this Cambridge index, the energy consumed by the Bitcoin network is comparable to that of some of the countries like Sweden and UAE. Here's a summary slide on Bitcoin. This is a busy slide, but it'll highlight some of the drawbacks. So the original idea of Bitcoin is about creating a digital cash on a decentralized peer-to-peer network that nobody can control. However, some of the drawbacks include Bitcoin is a very speculative asset, not behaving like a stable cash, because cash, you would expect some stability, right? If you're sending one Bitcoin to someone, it's, you know, the price could go up or down within the 10 minutes. By the time they get it, it will be a different value. So it's not stable like cash. So it's highly volatile. It's not under the control of peers anymore. These are like run by centralized, now it's all centralized mining pools. Like you can see, if you add the top 4 mining pools, the ones here in the boxes, right, it's around 59%. So they could actually collude and add the next block. And the third issue we talked about was the energy consumption. However, this Bitcoin concept actually led to a whole new field called blockchain, right? And this slide shows you how this whole thing evolved with the start of Bitcoin. Like you can look at it as 3 phases. Phase 1 or blockchain 1.0 basically was started with the launch of Bitcoin, and based on Bitcoin, hundreds or even thousands of cryptocurrencies were launched. And then the second phase, you can see blockchain 2.0 are called programmable chains. You can actually program conditions for the transfer of asset. And around 2015, Ethereum, Corda, Hyperledger, blockchains were launched, where all of them fall under the category of programmable chains. And then blockchain 3.0 is where a lot of architectures were launched to address the limitations of, you know, blockchain 2.0. Okay, now some of the terminologies that you would come across are shown here. So we've been talking about blockchain so far. Blockchain is basically a chain of blocks, right? Each block consists of a batch of transactions. There's even a broader term called DLT, distributed ledger technology, that actually, it just simply means, you know, it's append-only store of transactions on a distributed computer network. And it turns out that blockchain is a subset of DLT. You know, it's just grouping transactions in a certain way and creating blocks, right? But overall, DLT is basically transactions stored on a distributed computer network. And DAG is another type, or data structure, or DLT type. If you want to look at a generic architecture to understand a blockchain DLT, everything is built on a distributed computer network, right? And the definition is here. A distributed computer network is a collection of autonomous computer nodes, computing nodes, that appears to users as a single coherent computer. By the way, even Azure or Google Cloud, whatever cloud services you use, they are based on distributed computer network. So it's, the difference here is the protocol, you know, that makes the difference between the cloud services and the blockchain networks. The protocol that defines the rules, parameters, how the transactions are approved by the validators in the network. Remember, in the case of Bitcoin, validators are miners. You know, miners basically add the blocks, and they're the ones they get rewarded for being a validator on the Bitcoin network. So validator is a generic term used for blockchain DLT in protocols. So we have 2 technical aspects here. It's the ledger, and then there's the protocol. So ledger is where the transactions are stored. You get transaction layer, and the protocol layer where the governance happens, the governance layer, right? The rules. Now, once you understand those 2 concepts, you can actually understand the blockchain architectures. So let's look at, you know, the 2 types of ledgers. Right? Ledger could be public or private. So let's say you create a Google Sheet and, you know, you make it open to everyone. So anyone can actually see the Google Sheet on Google Drive. That's a public ledger. The similar concept applies to the blockchain ledger. So if anyone can see the data, like Bitcoin is a public ledger, anyone can see what's happening. That's why they're able to track a lot of the criminal activities. Everything is there. And then Private type means like, going back to the Google Sheet or spreadsheet example, if you just give access to a few people that you know, that's a private ledger. So there are two types of ledgers, right? Public ledger, everybody can see the data. Private ledger, only a close group can see it. Now the protocol, see, the protocol is the one there where the governance rules are programmed, right? So the protocol validators could be open group, an open group meaning anyone can become a validator, which is the case in Bitcoin network. Anyone can become a validator. And the other type is closed, right? Only a select group can be a validator on the network. So now, if you can use these combinations and come up with these three different architecture types. So public permissionless type blockchain is basically a combination of a public ledger, where the ledger is visible to the public, and open group validators. Anyone can become a validator. Remember, we talked about these miners. Anyone can become a miner, but of course you have to have enough computing power. Now, let's talk about the second type, where the ledger is public, but only a select group can actually be a validator. And there are examples here. EOS blockchain is like that. They have a public ledger. Anyone can see the data, but only a select group of people, basically can validate the transactions. I think they have like 21 validators in this case of EOS blockchain. And now the third type is private permission type. So the ledger is private, and only a closed group of validators can actually approve the transactions. So it's a private permission type. Private ledger, permission type. So if you understand these three architecture types, actually you will be able to follow the rest of my presentation, or actually you will understand the blockchain ecosystem much better. So you have the public permissionless type architecture like Bitcoin, Ethereum, and then you have public permission type, EOS blockchain. So this is semi-centralized, because it's controlled by a group. It could be like 20 or 100 validators that control or approve the transactions. And then the other one is centralized. It's purely a private ledger used by enterprises and governments. So a lot of the startup activities happening in the top two, and then governments, enterprises are using the private ledger. So let's go through some of those in the next few slides. We have to spend a few minutes on the Ethereum blockchain and understand some terminologies before we dive into these sections where what's happening in the startup space, enterprise space, government. Here is a comparison of Bitcoin versus Ethereum, right? The purpose of Bitcoin was serve as an electronic cash. What's different about Ethereum is you can start doing conditional transfers, meaning you can program certain conditions like if, then, all those, and if certain thing happens, the asset in account A gets transferred to account B. So those are some conditions that you can program. So virtual machine enables that programmability. And that's the big difference between Bitcoin and Ethereum. It's the virtual machine feature. Now, smart contract, turns out it's neither smart nor a contract in the sense of legal contract. It's just the term that folks in the blockchain field started using it. A smart contract basically is like any other computer program. The only difference is you deploy it on the blockchain network. And what happens is when it executes the transactions, it records the outcome. Like when I say outcome, like transfer of asset from user A to user B or user B to C, and it'll be stored on the blockchain. In the case of Ethereum, the smart contracts can be programmed in Solidity, Java, or Python. So to be able to execute transactions on these networks, any of these networks, you have to pay. So the transaction fees are basically paid in terms of the native asset at the protocol level. So in the case of Bitcoin, it's called Bitcoin. And in the case of Ethereum, it's called Ether. So where does this money go? Well, remember we talked about miners, validators. They're the ones who actually maintain the integrity of the network. So these fees, they go to them for keeping the network safe, right? Native asset are referred to as coins. So tokens are basically a programmed asset. And two types of tokens, fungible. For example, if I had $1 and Bob had $1, we can just swap it, right? They're the same value, they're interchangeable. Same thing, Bitcoin is, fungible. If I have one Bitcoin, and Bob has one Bitcoin, we can swap it, right? They're interchangeable. However, if I had a piece of art, it's unique, and Bob has a piece of art, different one. It's unique, right? We can't just swap it. And each one has its own value, and that's unique, not interchangeable. So on the blockchain network, you can create fungible tokens using ERC20 code, or you can create non-fungible token. Let's talk about applications. So the applications are running on top of the virtual machine. Applications may involve one or more smart contracts, and the front end would be like JavaScript, HTML, CSS. The next section is the cryptocurrencies and startups. Now, this slide shows the evolution of, starting with Bitcoin, back in 2009, which inspired the launch of altcoins, and there were stable coins for launch. We'll talk about that shortly. Ethereum enabled a lot of innovation that you see here. The programmable feature enabled like deployment of DAO, DeFi, NFTs, games, and metaverses. So also Ethereum inspired the launch of a lot of other blockchains as well. So if you want to see what's happening or how many projects are there, you can go to coinmarketcap.com. I checked today morning, it's about 17,834 cryptocurrencies, which is actually a combination of all coins and tokens. So some of them are infrastructure projects like we talked about Ethereum, but Ethereum is just one example, but there are many other chains such as Cardano, Solana, and so on. There are so many apps, dApps, and protocols being deployed on top of Ethereum blockchain. Similarly, on top of Solana blockchain, we can categorize those projects based on, the type of applications, like 525 DeFi projects. And then there's NFTs, 520 projects. There's games, there's metaverse. So let's talk about stablecoins. So remember we talked about how Bitcoin was very volatile. Early on, some projects tried to address that by launching a stablecoin where the value of the stablecoin is pegged to something. Like, for example, there could be a fiat currency. Like there are stablecoins where one stablecoin equals $1, right? That's pegged. So there are some stablecoins pegged to gold, for example. Digix is an example. So let's talk about DeFi. So DeFi is basically a peer-to-peer financial system that's built on blockchain. So you can basically do all the things that we do in the traditional world, like, lending, borrowing. Just to give you an example, let's say you have, a Bitcoin. You can actually borrow, and you can borrow up to, for example, like maybe 50% of the value of, Bitcoin. Just to give you an example, let's say today it's like 38,000 something, and half of that you can like 19,000. The protocol would let you borrow $19,000 worth of stable coin. So your one Bitcoin is locked into the protocol, right? And then you get 19,000 US dollars in stable coin, just like if you had an asset in the real world, like gold, You can borrow money from gold, right? And you do something else, same thing here. Folks would, with crypto assets, they use these protocols to, borrow money, and they take the money and they do something else, invest in some other coin or project. And the right side, this shows top 10 DeFi protocols, like, lending is one. And then the other thing is DEX. DEX stands for decentralized exchange. There are protocols that would enable you to swap, one crypto asset to another crypto asset without having to convert it. Like you can go from, for example, Bitcoin to Ethereum, and the protocol would do that. You don't have to convert Bitcoin to US dollar and then go from US dollar to Ether. The protocol would directly enable you to convert or buy Ether using Bitcoin. So if you see this graph, it shows you, the total value lot as of now is $195 billion. And this shows breakdown of, different blockchains. For example, 114 billion on Ethereum. It's a combination of all protocols add up to this value. So non-fungible tokens or NFTs are unique and non-interchangeable digital asset, which is basically a smart contract program, ERC 721 to be specific. There are also other variations of it, like ERC 1155. Basically, it's digital ownership of digital files such as photos or audios or videos. And you can see a breakdown of who's using this right now. Is art, gaming, sports, collectibles, and so on. And this just shows you an example of one of the biggest NFT sales. Let's talk about games. Half of the world population is playing games right now. And, blockchain basically can enable a new kind of, economics here. So what happens is, remember we talked about a wallet, right? A user can have a wallet on a blockchain, and players in blockchain games, they can actually earn tokens. So they get rewarded for playing the games. And the interesting thing is now these tokens have value, right? You can sell them. So this interesting, economics enabled by blockchain tokens is also, is being carried over to next topic, which is like metaverse. So metaverse basically it combines, the physical world that we know with the virtual world, like we heard about this AR, VR, mixed reality, MR, and also this virtual economy created by the virtual digital assets, specifically blockchain-enabled coins, tokens. You can actually own assets in one virtual world, and you can take it to another virtual world. And just to give you an example, folks are, buying like virtual land, building, like a city. In fact, even big companies now are doing that. I think Samsung and even JP Morgan, they're buying land in these, metaverses and building their own city, or could be like a pavilion for visitors. Now, I'll move on to the next topic, DAO, which is another concept which became pretty popular in the blockchain space, where an organization that's completely represented by smart contracts. So you could basically create a community that actually governs the decision making of an organization. And sometimes, there's no physical entity for DAOs. And it's a contract, smart contract, or it could be a bunch of smart contracts that community actually gets to decide how to manage the assets owned by the DAO, and they vote on it. And for example, There could be multiple proposals on which project to fund, and the community would vote on it, and the DAO would fund that project. And there have been several different types of DAOs, and you can see here. Now let's talk about the decentralized internet architecture. So there are folks who have even a bigger vision in the blockchain space to extend the ideas and concepts developed over the last few years, a decade now, to add them all together to create a decentralized internet. So here it shows the architecture with various components, right? You have the computing, which we spent quite a bit of time on, Ethereum and all these other blockchains. So that's one component, right? Computing part of it. And then there could be storage, and then there's messaging system, there's a naming system. We talked about DAO, and then we can have a decentralized browser. We talked about decentralized applications. So you could, theoretically combine all these pieces and create a decentralized internet architecture that does not depend on a single authority or censorship resistant, so nobody can bring it down. And so there are a few projects. You can see the list here: Web3 Foundation, Tron, Internet Blockchain Foundation. There are a few example projects here on decentralized storage, where the data is stored on multiple computers. And there's also the messaging protocol like Whisper, Waku Secretum, and there's also domain naming system, right? There's ENS, Ethereum Naming Service, Unstoppable Domain. So that's another component of the decentralized internet architecture. And there's also a browser. I don't know how many of you have tried Brave. Brave is a browser which actually has a token. It's called a BAT token. So you get rewarded in terms of BAT tokens if you use the browser. Now let's talk about enterprise use cases. So this slide shows various use cases pursued by the top 50 companies in the blockchain space. These are big companies, and you can see capital markets like banking, finance is one. The other one is supply chain in terms of tracking. For example, Walmart looked at a use case where you can track food from the farm to the store, and also in the pharmaceutical industry, you can track whether the medicine came from the right supplier. You group them based on the technology used. It turns out the top four are Hyperledger Fabric, Ethereum with privacy implementations, Quorum, and also Corda. Companies have been coming together and creating alliances to build their own private blockchain, or sometimes tools, and sometimes standards, specifications. So just to give you an example, like Mobi it's a consortium of all the automakers. They got together, created this consortia, and they're looking at how to use blockchain for example, vehicle identity. This is an interesting data that the ESG intelligence say that there's over 433 consortia, meaning like companies coming together, creating either to build their own blockchains for their whatever the use case is, or application like IoT or transportation. In fact, all the cloud companies, they started launching their blockchain as a service to their cloud platform. And it started with IBM, the Hyperledger Fabric, and Amazon, AWS, Oracle. And in China, we have Tencent, Baidu, Alibaba. They all have their own blockchain as a service, or BaaS platforms. This slide shows various organizations working on standards. So we have four categories. We have A, which is international standards organizations. We have IEEE on there. And we have B, we talked about B, industry alliances, where the companies, enterprises coming together to create industry specifications and standards. And then we have open standards organizations. There's been some work on trying to create open standards for blockchain by Oasis. And then open source. All these projects are open source projects. Bitcoin, for example, there's a process that they developed called the Bitcoin Improvement Proposal, BIP. Similarly, Ethereum, these are communities, it's just community of developers. And they're all over the world. Ethereum community has a process called EIP, and Ethereum Improvement Proposal. So that's their way of, submitting a new proposal, review, and if it's accepted, then they implement the code, right? Now let's look at some government use cases. So this list shows some of the popular use cases like digital currencies, taxation, welfare distribution, identity, and so on. So let me go through a couple of those quickly. Central bank digital currency. So the idea here is governments don't need to print paper money anymore, paper or coins or whatever. It'll be completely on a computer network. In this case, would be a private blockchain controlled by the government. And as a matter of fact, China is already, it's live, digital yuan. And there are other countries, basically they're piloting and at different stages. I think over 80 countries are currently looking at CBDCs. In India, blockchain is used to basically eliminate spam calls for mobile phone market, where they created like a consortia of the regulatory authority and the telecom operators, mobile phone operators, and they basically have to be registered. Whoever wants to send messages to, you can see here, RTM, registered telemarketers. So they need to be registered and they have to follow certain rules. They can only send so many messages and all that, right? So it went live, and apparently, 500 million mobile phone customers are using this service or going through this service. So this is one of the large scale use cases of blockchain. And in this case, they use Hyperledger Fabric. Here's another big project. This is being funded by the European Commission. They're building a common infrastructure for use by the EU member states, where they want to issue identity. So it'll be like seamless. For example, if a person, a European citizen, is in Poland, they have an identity in Poland, and they move to France, and they'd have to get another identity in France. So it's kind of similar to what happens in the US. Every state you go to, you got to get your driver's license, right? They want to solve that by issuing a single identity on a blockchain that could be verified, throughout the EU. Similarly for degrees, diplomas, if a student goes from Poland to Germany and they have to wait for some time to get all the transcripts and degree and all that, but here they want to put all the degrees, credentials on blockchain, run by, primarily backed by the EU. This is a government blockchain. This is a report that was published by United Nations about looking at some social impact projects. Like blockchain could be used for land record management. Other use cases such as cash transfers to refugees, because a lot of refugees don't have identity and it's hard to create a bank account without an identity. So you can have a wallet on a blockchain where somebody could send you, money. So that's the advantage of blockchain, where anyone from any corner of the world can actually create a wallet, and you can send Bitcoin to them or whatever network you use. And it's not controlled by anyone. Nobody can shut it down. That's the end of my talk on blockchain, and please check out the website blockchain.IEEE.org. And we have a lot of activities going on in the Blockchain Initiative. It's been running for about 5 years now. And we have several blockchain groups all over the world, 50 groups. As I said, I used to travel quite a bit before the pandemic. So we launched, I got in touch with the local IEEE volunteers in different cities that I was in physically, and we got the group going. And they used to meet face-to-face before the pandemic. But now we're doing virtual meetings. And currently we are pursuing a project. We funded like 5 POCs last year to build a blockchain-based transactive energy network, where You could trade energy, like let's say you have a community that owns like, solar panels, and they can generate energy and they can trade with their neighbors, right? So blockchain could enable these transactions, or you could store the, transaction data. And we're funding a, few projects. Here's my email address. You can also connect with me through LinkedIn. So I'll stop here. I guess I see 42 comments.
Yeah, so a lot of the comments, kudos to the folks on the chat here, because I know a lot of our participants were answering questions for other participants. So I guess one of the themes here is, so I'm going to go with themes, and maybe if people can re-enter their questions if they didn't get an answer, because I said there's a lot of activity, is how do you get a Bitcoin into US currency or cash? How does that transaction happen where people get money for it?
So you could use an exchange. Coinbase.com is an exchange. Anyone can create an account, and you can convert it. You can actually link your bank account to your Coinbase account, and you can basically transfer money from your bank account to Coinbase and buy from Coinbase account, Bitcoin, or the other way around. You can actually sell Bitcoin, and then you can transfer from the Coinbase account to your bank account. But this is going to change pretty soon. Apple just announced a couple of weeks ago that they're going to link the crypto wallet to the Apple Pay. So you can basically just directly pay out of your crypto wallet. You don't need to transfer anymore. You don't need to do the selling of Bitcoin to US dollar, because once you link up the crypto wallet to the Apple wallet, just like, today we add our credit cards to the Apple wallet, you could add your crypto wallet, but you still have to have a wallet like Coinbase account, for example. And if you have a Bitcoin and Coinbase sitting there and you link the Coinbase account to the Apple wallet, directly you can purchase. So that's, you can just search Apple and crypto, you will see that in our news.
Okay. And another series of questions regarding orphaned Bitcoins. So you have people who've lost their key, or people die without revealing their key. What happens to those Bitcoins that get quote unquote lost?
What happens is there's a few questions, right? One is lost. Lost, it's gone. There's nobody can get it back. You need the private key, to basically recover the asset. If you lost the private key, that's gone. The asset is on the network, but nobody can use it. And that's another thing that, you asked about, somebody died. So what happens is, somebody dies and only they know the private key, and nobody knows the private key. It's gone again. Nobody can access it. So that's where, if you have an account with a centralized exchange like Coinbase is a company, I guess you can then, prove to them that, you're related to that person, and, and you probably have to go through some, legal paperwork with a lawyer and all that. But if you prove that you're related to the person, Coinbase would give you the access, because they have the private keys. They have the control of the account.
Another question that's come up is in regards to the energy consumption. And I know I've had friends in the past who had, personal rigs in their basement, a couple of graphics cards, and eventually the cost of electricity becomes prohibitive. So at this point, I know with Bitcoin being 38,000 up to 70,000 at one point,
yeah.
At what point does the energy usage become so prohibitive this basically just stops?
Well, it's stops in the sense, like, you mean like
it doesn't pay to mine or do the transactions.
Yeah. So that happened. Like, even there was a time where if I go back to this graph here, right? So right now it's what today, around 245K for one block. But there was a time where the cost of mining was more than the reward. A lot of Bitcoin mining company went out of business during that time. And some of them were running in loss for some time, hoping, things will turn around, which it did. So it can happen. Could be a scenario where the cost of mining is more than the reward. It won't make any sense for these mining companies to mine. I can add more on the mining topic.
No, go ahead. Keep going.
See, back in 2019, 75% of the mining was happening in China. And China pushed them out because in a lot of these mining companies were buying coal plants and, using energy produced by coal plants. And of course, as you can guess, they were producing a lot of, CO2 emissions and polluting the environment. So they pushed them out, and it became almost zero as of like August of 2020, 21. And even if you look at the, right now it's primarily in the US and Kazakhstan and Russia as well, mining. And the Bitcoin network is going to continue to consume power. The other issue is the e-waste. So there is this difficulty factor, which we didn't spend much time talking about it. So the difficulty for mining goes up over time. As a result, you need, sophisticated hardware to do the mining. So after like some time, like few months, the hardware that you use is just useless. You can't mine anymore, and they produce a lot of e-waste. So energy consumption is one issue, but e-waste is another issue. Ethereum is also using proof of work algorithm. It also consumes quite a bit of power, but it has a leader, and the leader is pushing for a change of the network from proof of work algorithm to the proof of stake algorithm. So that's going to reduce the power energy consumption significantly. Like this shows you, you can see here, graphically, right? It'll be like 84,000 or 84 kilowatt hour per transaction currently on the Ethereum network, and it'll go down to like 35 watt hour once they switch to the proof of stake algorithm. This is from a recent research that, it's a comparison of energy consumption of like Visa, and Bitcoin and other networks. So a lot of the new ones, like I called it as blockchain 2.0 or actually 3.0, they actually use proof of stake like Algorand, Cardano, Polkadot, and all of them. And Ethereum, as I said, they're also switching to a proof of stake algorithm, and the power consumption would not be an issue anymore.
Yeah, just one final question, because I know we're running a bit long here. So one of the themes here has also been criminal activity. We recently had the rather comical case of the couple that tried to launder $4.6 billion in Bitcoin, and were pretty quickly caught. So how is Bitcoin being used to facilitate criminal activity, and what are governments doing to kind of break that?
So there are companies that are tracking the transactions. That's their business model, to track people, track transactions and huge volumes, and they actually report it to the government, IRS and Homeland Security. So as you just mentioned, right, they get caught. FBI caught these folks, and they track, and what happens is when there are some Bitcoin, everything is transparent. You can actually see where the money is going, like from user A to user B. The key part is, when you cash the money out, like when you take the money to the real world, you have to have an account somewhere. Like you have to have an account with an exchange, typically an exchange. And you convert, like somebody asked in the beginning, right? How do you convert like one Bitcoin to US dollar, right? US dollar. So you have to have an account with an exchange. An exchange knows who you are, right? Because you have to provide them information like your passport, some ID. When you create an account with any exchanges, typically operating in the US, they would want to know who you are. They do verification. So if somebody is trying to cash out the money that was linked to one of the criminal activities, that's how they find out, right? That person has a link to that. Because everything else that happens on the blockchain, you can see exactly where it's going, what's happening in the Bitcoin network, right? So if somebody got hacked, like in this case, like many years, correct? They've been watching this, and then finally found out when this person was trying to move it to a real world, they found out the person. But there's even more complicated networks where you could actually run it through some privacy coins like Monero, there's Zcash. They use some very sophisticated algorithms where they basically mix everything and you kind of lose track or trace of where the money is going. But it's an ongoing thing, but this is where there's a whole, bunch of companies like, Chain Analysis, and several other companies are actually doing this. That's their full-time job of tracking, the money on the Bitcoin or crypto network. And they, in fact, publish reports on criminal activity and things like that.
I know there were a few extra questions in there. I do apologize since we're running a bit long here. What I will do at the end of this, I will send out a link to the recording since it's on the cloud, and I will send out the slides. If Dr. Ramadoss, if you could send those over, I will forward those to everybody on the call. And if you have any additional questions, feel free to reach out. And again, Doctor, thank you very much for this presentation. This was really, really good. And I know it was technical enough for the folks on the call, I'm sure.